everything. Once again, hopefully you guys have been noticing I'm on top of my game and actually uploading the website. I'm on top of myself. Okay, so this is 1-1. So today we're going to start with polynomials. Okay, what makes something a polynomial? Anybody know? Huh? Okay, so I'm going to write some things up here and you guys tell me if it is a polynomial. Uh-oh. Whoa. What the heck happened? It just vanished. We'll start again.
What's the 4 plus?
So this is square root of x minus 1. I guess I should have f of x here. I apologize. Or y equals. Okay, so I have 3 different equations. They're all equations, right? They're actually all functions. Does anybody remember the definition of function? For every input, there is exactly one output, right? That's the definition of function. Okay? These are all functions. But which one is a polynomial? A, B, or C? Somebody says an answer. I just put it right here. What did you say? Oscar, right? A would be a polynomial. Notice this is called a rational. This is our square root function. This is a quadratic. Notice a polynomial is in terms that have rational exponents. Excuse me, not rational exponents. Natural number exponents. You guys remember what natural numbers are? Our counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so on. Does not include 0. Okay? Wait, function is for every input there's exactly one output. Okay? So this would be a polynomial. Okay? So let's go through them all. So if we just had f of x, I guess it is even our whole number. Because if I said f of x is 4, is that a polynomial? It is, because this is times by x to the 0. Okay? And what's anything raised to the 0 power? 1 times 4 is still 4. Okay? We would call this a constant. Okay? Because it's just 4. It's always going to be 4, never going to change, right? Okay? How about this? What do we call this style? What does that look like? A line, right? So this is called a linear. Notice this is also called a binomial, right? Because 2 terms. What would this be called if I just had the 4? Monomial. What if I just had 3 f's? Is that still linear? Still a line, right? So it's linear monomial. Okay. Okay, how about this? This would be a trinomial, because there's 3 terms. So with me on that. This would be called a quadratic, because the highest power is x squared. Now, let's name what one is the quadratic part. What makes this a quadratic? What term? The 4x squared. What's this called? That's our linear term. That's the part that makes it a linear term. But overall, this is a quadratic with a quadratic part, a linear part, and a constant. So bear with me on that. Does it have to have 3 terms to make it a quadratic? We've seen a graph y equals x squared before, haven't we? That's still a quadratic, but it is a monomial, correct? Then we have this guy. What would that be called? The cubic binomial. What kind of parts do we have in it? We have a cubic part and we have a constant. Make sense? What if it had, though, something like that? Still cubic, has all the other parts within a quadratic, a linear, and a constant, right? So this is a cubic equation. Okay? What would we call this, though? More than a trinomial. Say what? All of them are polynomials. Because poly just means many. Okay? That's a good thing. Quadnomial sounds right, but it's actually anything above 3 we just call it a 4-term polynomial, a 5-term polynomial. Does that make sense? This would just be considered a 4-term polynomial. Thanks, man. That is awesome. Awesome. Yeah! Yeah! See how it works. Okay. Now, if it's raised to the 5th power, I don't know what the hell we call it. Anyway, leave it be. Okay? But, what would that be? We just call it a fifth, what do we call it? 5th degree. Okay, have you guys ever heard of the word degree?
No.
So, no, not that kind of degree. So, this would be degree 3. Just means what's your highest power. Okay? So if I had it next to, like for example, what if I had this? It'd be degree 5. It's the highest power. Because what the degree does is it dictates what the graph will look like. Does that make sense? Okay. Are we okay with knowing what does standard form mean as well? Is this in standard form? These guys aren't. Because notice I'm going from decreasing powers down. Right? Is this guy? How would I put him in, what's it called? Standard form. Thank you. I just said it, but I lost it. So this way it would be negative x to the 5th plus 4x squared. That would be standard form. Okay? We all good? Nothing hard so far, really, right? Just vocab. Okay. Well, we also, with that degree, we can talk about turning points. Okay? Let's think about a line. What does it look like? Like this. How many turning points do we have? We have 0 because it's consistently going the same direction, right? Okay, I want to see if you guys can find this out. So a linear raised to the 1st has 0 turning points. Okay? X squared, what does it look like? Right? How many turning points? 1. See how it's turning point? Because notice I'm decreasing, and then there's a point that I start increasing. Is everybody there with me? So I have 1. X cubed. X cubed could look like this. So it has 2 turning points. Notice increasing. There's a point that I start to decrease and I start increasing again. Make sense? How about X to the 4th? What do you guys think? You could have at most 3. Now, could I have, first off, X cubed, could I have 1 turning point on an X cubed? No. Because that means I would start here and then I'd come back down. I don't know if you guys ever noticed, odd degree, meaning 1, 3, 5, 7, whatever, okay, basically have this shape. As I go this way, I'll start going down. And then it'll go up. My body might be different. Like here, that's different than a line, right? Does that make sense what I'm saying there? But in general, it starts down, ends up. Correct? How about any even power? What will it always look like? My body might be different, but it'll always have this. Because you guys think about it, anything raised to the fourth power, everything will always come out even, right? Hence why it's above the x-axis. Now, is there certain parts that might play into it that makes it dip down? Yeah. But in general, as we get larger numbers, it's going to really go fast, and so it'll always be up. Does that make sense what I'm trying to say by that? Okay, so you might want to write that down. Let's try and finish up turning points. What do you guys think x to the fifth could be? 4. So what's the general rule? One left, that's the most turning points it could be. I could have 4 turning points. On x to the fifth, could I have 2 turning points? I could. Could I have 0 turning points? Yes, I could. So notice every time they actually go down in groups of 2. Okay, because if I don't go down in groups of 2, it changes my end behavior. What's next to the fifth group? Something like this, right? If I only had 3 turning points, 1, 2, 3, does it have the end behavior that's required for next to the fifth? No. Does that make sense why it has to always go down in groups of 2? Notice if I went to x to the fifth and I went down to 2 turning points, it might be really steep, right? A lot steeper than this one, because x to the fifth is faster growing than x to the third, right? Does that make sense? So I always have to go down in increments of 2. Working on that? Okay, so notice x to the fourth, it has 3 turning points. Okay, notice that would be kind of like that W. 1, 2, 3. Okay, but x to the fourth can look like this too. How many turning points? 1. Notice, see how it's kind of more flat, because when you're taking a half and raising it to the fourth power, it's very small. It's a half to the fourth. 16. Okay, that makes it very small. So it kind of like levels out. But there is 1 turning point. And there is a point that goes down to, and then it starts increasing back up, right? It can always go down in increments of 2, but I always will go 1 less, and then it should be, okay, if it's next to the fourth, it got 3 turning points, or 1 turning point. Okay. The key thing, guys, I want you guys to know, though, is the shape of odds. Meaning, when I mean odds, I'm meaning odd degrees. Okay, we'll always have this basic shape. So it'll always have something coming up and going up like such. Now, I left this blank because that middle part can be different depending upon how high a degree it is, correct? Okay? But it'll always have that type of shape. Okay, how about even degrees? What will they always have? They'll always have that shape, won't they? Does that make sense to everybody? Okay, these are what I call my math moves. Okay? I want to see them on the dance floor sooner or later for you guys. You can do a lot of dancing. Linear. Right? Like this one. And then now you're doing quadratic. Okay, now this, guys, do we know what a leading coefficient is? Give me an example. Tell me what the leading coefficient of this equation is. 4. Okay, x squared tells us we have this shape, because anything squared is going to put me up as I get to the infinity. The farther I go, the bigger it's going to be. And it'll always be positive, because anything squared is going to be positive. You guys with me? Hey, what does that 4 do? Just extends it higher, doesn't it? Okay, so my leading coefficient here, if it's positive, gives me the same thing. But what if I change that to a negative 4? We go from scoring a touchdown to fat man walking. Okay? You gotta have your arms out so making your stomach so wide. Okay? So he'd really walk like this. Anyway. Okay? So your leading coefficient can flip it. So we went from here to here. Notice the end behavior is going in the same direction now for an even. Either they're both going up or they're both going down. Correct? Here is what the leading coefficient of a normal odd degree looks like. Right? What if my leading coefficient becomes negative? I'm telling you guys, dance moves. Boom, 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 boom. It's fun. Just get out there and have fun. Okay. So, think about that. Think about what the degree gives me. If it's odd, if it's even, and then think about what the leading coefficient does to me. Right? If it's, there's an even positive. Here's an even negative. Right? Is everybody with me on that? Okay. So, we're going to do what we call end behavior. Now notice, like I said, the body of the graph might be different, right? You have lots of curves in there, but in the end, if it is an odd degree, these parts are going to take over, aren't they? And you start getting further and further away. You guys see what I'm saying about that? Because if it's x cubed, and I might have all this other crap with it, but as x gets really, really, really small, being like going to negative infinity, when I cube that, that's a very, very, very large small number. You get what I'm saying? Because it's definitely a small number as it goes down, right? But it grows very quickly, right? As we go this way, as it gets larger, that thing's going to take over and just start skyrocketing, right? Okay, so let me show you. Let's say we have this equation. Let's say we have this equation. Negative 3x squared plus 4x. So let's talk about it. What should our graph be looking like because of its degree? Think just degree right now. We should be going up, right? For just the degree, as of the degree. Okay, but because of the leading coefficient, we're going to flip us down. So I don't really care what this graph looks like. I know it has something of that shape. You guys agree with me on that? That's not an accurate graph of what that is. And I don't care. Because my goal is to say, what will this graph do with my end behavior? And end behavior is this. It's saying as x goes to infinity, what is y doing? So as my x's are going this direction, what's happening to my y? They are decreasing or going to negative infinity. As my x's are going to negative infinity, what are my y's doing? They're going to negative infinity. This right here, guys, is called end behavior. Meaning, sure, does this stuff win out sometimes? Meaning, does this take larger numbers than this part occasionally? Let's show you a half. 4 times a half. 2. This is 2. What's a half squared? 4. 4 times negative 3 is negative 3/4. Who's larger? 2 or negative 3/4? Hence why the linear part won. Right? Does that make sense? Hence why we have this positive, because he's bigger than the quadratic part when I plug that number in. Yes, no, a little bit. Okay? That's why the graphs can be all the way over there. But in the end, as I get to those big honking numbers, 1 million, 2 million, who's going to win out? The quadratic or the linear? The quadratic, because if I square 1,000,000, whoa, that just all of a sudden is a huge number, right? So therefore, sooner or later, the quadratic's going to win out. Yeah. You have a question? So this is called end behavior, right? Always say as x goes to infinity, what's happening to my y? As x goes to negative infinity, what's happening to my y? Okay. If it is an even degree, shouldn't your end behavior going in the same direction? Whether it be both going up to infinity or both going down to negative infinity, correct? If it's an even degree, they'll be going in the same direction. Yes? Feel good? You're looking at me a little weird. Talk to me if not. Let's do another end behavior. All right. What degree is this? Degree 5. Highest power is 5. Degree 5. Okay? Who is my leading coefficient? The 5 in front of x to the 5th. Even though it's not leading, but it's not in standard form, is it? So therefore, if I put it in standard form, it would be leading. Agreed? You guys okay with that? Okay? Okay. So, with that being said, yes, the highest power is 5. So, what's our end behavior? What is our generalized graph? Could look like this. How many turning points could I have? 4. Let's do 4. 1, 2, 3, 4. Okay? There's my axis. I just made it up. I don't even know what the heck this graph looks like. But here's a rough gist of what it could be, right? Am I going in the correct way because of the positive leading coefficient? Okay? So let's do our end behavior. As x goes to infinity, what's y doing? That is what end behavior is. But you've got to do both sides. I did the positive side. Now let's go as x is going to negative infinity. What's y doing?
Warm in this room.
You're telling me, brother.
Feels great.
As x is going to negative infinity, what's y doing? Negative infinity. Okay? Awesome. Any questions so far? This is really what's happening for your lesson. Now, okay, I gotta think here. Here we go. Oops. There's 2 in there. All right, here we go. We got a table here, and I could write that table better. I have x is -1, x is 0, 1, 2, and 3, so basically -1 to 3. The results for those are 2, 1, 2, 5, 10. Okay? Is this linear? Is this a linear table? Can somebody tell me why? Say again? Okay, and remember, a linear would not have a change, because that means somewhere I have a change. Okay, so this is not linear. It's not obviously constant because it's not the same value. Okay, so also remember, linear means that it would have a constant slope, meaning it's going up or down the same amount, right? You just go up, it's down the same amount. Okay, so what we're going to do, I know Ms. Burton teaches this. I don't know if anybody else does, but we're going to do our first difference. Okay? And we're going to say, how does 2 get to 1? What happened? We went down 1. Does everybody see that? What happens from 1 to 2? We went up 1. How did 2 get to 5? We went up 3. How does 5 get to 10? Okay, on our first difference, it is not 0. 0 means that it would be constant because it's never moving. Yes? Is everybody with me on that? Okay. If it is a linear function, your first difference will all be the same because they have a common slope. Okay. Is our first difference the same? No. Let's check our second difference. How does negative 1 get to 1? We went up to 2. How does 1 get to 3? We went up to 2. How does 3 get to 5? We went up to 2. See how it's constant. Guess what kind of equation this is? A quadratic. What if your constant was on your third term? Or your third difference? It would be a cubic. What if it's on your fourth difference? 4 terms, right? I mean a fourth power, or a fourth degree, or a fourth sixth, or whatever. Okay? Does that make sense? What about the fifth? You're on your fifth power. Okay? So understand, this is actually a calculus. After differences, we can find slope. They're called derivatives. Okay? So we can go ahead and find them. You guys want to come back and grab the homework later, though? Okay. Awesome. So we can tell what kind of an equation it is just by looking at the data and finding the differences. Okay, we keep going. Now, is every equation in this whole world going to give me a difference, either 1, 2, 3, 4, 5, or all the way through infinity? No. Because if it's a square root, that's not a common difference that's going to find me anymore. Or a rational, or some other function. Okay? But if it is a polynomial, keyword, if it's a polynomial, we will be able to find out what type of degree that's going to be. Make sense? Yes, no? Okay, once again, if it's the first difference and it's constant, that is linear. Second difference, quadratic. Third difference, cubic, and so on. Okay, be very careful, because sometimes your numbers get messed up, like here, people are like 2 to 1. Oh, that's a 1. Because they're thinking it's just 1 unit away, but it went down 1, right? Does that make sense to everybody? So also put on it go in a positive direction or a negative direction away from that number. Okay? With me? All right. Okay, yes, sir.
So how does, on the second difference, how does it
Okay, how does negative 1 get to 1? How does 1 get to 3? How does 3 get to 5? How many of you guys have ever seen that before? Just curiosity. How many of you guys have done the first class? I was like, because I knew she did that. Okay. All right. How many of you guys have your calculators yet? Yeah, that's not too bad. Here we go, ladies and gentlemen. We're going to go ahead and find increasing and decreasing. Okay? So we'll calculate that. Here we go. First off, I'm going to put him down there really quick. Okay, really quickly. Here I'm going to graph something. Let's say this point is at negative 1, 1. This is at 5, negative 2. Okay? We have different parts here. How many parts of this graph are increasing? 2 parts, correct? Those 2 parts would be this and this. You guys agree with me on that? Those parts are increasing, meaning as x is going to the right, my y values are getting higher than the previous time. Do you guys agree with that? As my x values, did I say x values? As my x values go to the right, my y values go to the left. Right? Okay, let me ask you this question. If I'm walking up the stairs, okay, if I'm at the bottom, am I increasing? If I'm standing here and I haven't made a step yet, Am I increasing? So what makes me start increasing is this forward motion, right? Does that make sense to somebody? So I would like us to talk about what intervals, or interval could be only one, where this graph is increasing. Where is this graph increasing? Always is on the x-axis. Negative infinity to negative 1. So here's my question. Negative infinity we can never be to, right? And never touch it, so that's right. But am I increasing at negative 1? No. Am I decreasing at negative 1? So I'm neither at that point now. It's like when you get to the top of a mountain. I've climbed the mountain. As soon as I got to the top, I'm no longer increasing anymore because I'm to the top. Right? Am I decreasing when I'm sitting at the top? I'm just climbing there. As soon as I start making my step down, that's when I start decreasing. Right? There's not a specific point that I can actually say that I'm increasing because we go all the way up until when we get to the top. And like I said yesterday in one of my classes, somebody tell me what's the largest number smaller than 5? Is there one? The largest number smaller than 5? I agree, but as you said, 4.9 repeating it, I agree with that. But in general, there's really not one, right? Because there's always a larger number after that. Correct? We have 4.999. There's 4.99999. Right? You get what I'm saying? So can we ever really find the largest number less than 5? So hence why we have to say it's all numbers up to 5. Right? Does that make sense what I'm trying to say about that? Okay, what's my other interval where it's increasing? From 5 to infinity. With parentheses and use your little if there's more than one, you got to put a union in between. Okay, where is it decreasing? It'd be from negative 1 to 5. Everybody with me on that? Yes, ma'am? No, ma'am, because once again, brackets means what? Include. So that's kind of like that same thing. When I get to the top, am I really there? Does that make sense to me? You can grab these worksheets over here. There's more that's one in your hand out there. Thank you. Okay, so we're going to hurry and go on to our graph just so you guys understand how to do this. So with your calculator, once again, if you don't have a TI, I understand you can more than welcome use any calculator, but it's on you to know how to do the work. Does that make sense? Okay, so I'm going to clear him out. All right, so here we go. I'm going to graph something. Y, we're going to go to y equals. I have something in here, so I'm going to hit clear. I'm going to try my best here, guys, and if you get lost, I only have a few minutes, so we got to keep going, okay? And I can help you if you need to. So I'm going to do the equation 3x squared minus 4. Just something very easy. Actually, let's make that 3x cubed. Cubed minus 4x plus 1. Okay? 3x cubed minus 4x plus 1. That's what I plugged in. All right, we're going to make sure everybody has the same window. And if you don't quite, or if you're not following along, I got to keep going. Sorry, trying to rush through this. I'm going to make sure everybody sees the same. So I'm going to hit zoom 6. That gives me my 10 by 10 window, meaning negative 10 to 10, negative 10 to 10. Okay, that's a standard window. There's my graph. How many turning points do I have? 2. And that could be possible because it was an x cubed, correct? Notice we have a high point and we have a low point. I need to find out where those points are if I want to know where it is increasing and decreasing. Correct? Okay, so here we go. I'm only going to show one. Really quick, just stay with me. Where does increasing? So if you hit second, calc, you see the calc button. And you see how it says, we're going to do the minimum. But there's also a maximum point there. So notice this is the minimum point, that's a maximum point. Does that make sense? Okay, look what it says. It says left bound. Be to the left of the minimum. So I hit enter. Now it says right bound. So I push over to the other side and I hit enter. Hit enter again. Notice it gives me a point of where that low point is. So that I can figure out where the increase and decrease is. I believe there's only one question on there. If you don't get to it, it's okay because we didn't get it all the way in here. Have a great day, guys. See you guys Tuesday next week. Have a good weekend. To Mr. Jones or Mr. Barker? Okay, awesome. Thank you. I can help you, or just Google it. If you can do it, you might just have to start learning how to do it over something. And just kind of get the general idea. Okay, how do I find?
I got 5 pages left.
No, you go to your class, guys. Go to your class. Not in your assembly yet. Then we're going to go down by class. That makes sense. So I can help you. If you want to even come in after school, and then, like I said, a lot of your time Googling it can't work, and it has some similar ideas. It's not. Okay? Grab your notes, this paper, guys, so we're ready for when we come back from the assembly. Yeah, we'll be coming back. Okay. Yep, thank you. Very honest. Yeah!